Hey guys, I wanted to make a very short video kind of showing how to do the last page of the packet for this unit, the one that's Molecular Structures Practice 2D and 3D, because there's a few things not mentioned in the notes or on the last video that you need in order to do this. You'll also probably need your VSEPR theory chart, but that is in the packet right before this thing, so that shouldn't be an issue for you guys. Alright, this thing says, draw the Lewis dot and 3D structures for the following molecules. State the VSEPR molecular geometry of each molecule and the hybridization in the central atom. That word there is one we haven't heard before, hybridization. So we'll talk about what that is in just a second. Be sure to box your answer. Hint, show all lone pairs and draw 3D structures. Haven't done that either. Using these bonds. Alright, a 3D structure is just a way to draw on paper how it is going to look three-dimensionally. You do that by using lines to show in the plane, like actually in the paper, this triangular thing to show in front of the plane, like coming out, and then this dashed one to go back. Alright, so like carbon tetrachloride. Alright, I'm going to draw the Lewis structure for carbon tetrachloride. This guy has 4 valence electrons. Chlorine has 7 valence electrons times 4 chlorines. So 7 times 4 is 28, plus 4 is 32 valence electrons. Alright. Carbon's obviously the center, so I'm going to put carbon in the center. 1, 2, 3, 4. Chlorine's going to go next to them. 1, 3, 4, 5, 6, 7. Meaning they're going to bond like this. So chlorine. So that means we're going to have a chlorine on each side. Like that. With 8 electrons around each chlorine, making 8 around the carbon. So 8 here, 8 here, 8 here, 8 here. 8 times 4 is 32. So you used all 32 valence electrons, okay? Okay, now it says to draw the 3D structure. I'm actually drawing these a little bit big. You probably want to move over a little more to have more space. The 3D structure is just the exact same thing as what you've drawn here, except we want to draw it in the actual 3D-ness. So something with 4 things off the center and 4 bonds is going to be a tetrahedral. Okay? So state the VSEPR molecular geometry. So this guy we know is going to be tetrahedral. Alright, so I've got the VSEPR molecular theory. I've got the Lewis dot, done that. And now I need to do the hybridization in each central atom. Okay, hybridization just means that the bonds that are coming off of the central atom here, they have been hybridized in the orbitals. Okay, remember these 4 spots that the bonds coming off of correspond to the 1s orbital and the 3p orbitals that make up the 8 valence electrons, because 2 go in the s, 6 go in the p's, that makes 8, and those are the only ones involved in valence electrons because they're always the furthest out. Thing is, it doesn't make sense that all these electrons, which all have equal energy, would be some in the s, some in the p's. So what the s and the p orbitals actually do is they like hybridize and form a hybrid orbital that creates an equal amount of electrons going in each direction, which is why the tetrahedral can exist correctly. Okay, so it might actually help you to label these on your VSEPR theory chart. Okay, if you only have 2 things coming off of the central atom, that means there's only 2 bonds coming off of there. There's only 2 things coming off. That means this is sp hybridized. Okay, because it only has 1 s and 1 p used to form the 2 bonds. The other 2 p orbitals are what we call pi bonds. So this is going to have 2 sigma bonds, that is the Greek letter sigma, and 2 pi bonds. Okay, a pi bond and a sigma bond, you really don't need to know what they are. Just know that sigma bonds are ones that are actually forming, whereas pi bonds are ones that are in like a double bond. So this doesn't have any double bonds, so this doesn't actually have any pi bonds. For this one that we're doing, it's going to be sp 3 hybrid. 1s and 3p's all hybridized together, okay? Which means you have 4 sigma bonds. Let's see, 4 sigma bonds. When you only have 3 coming off, that's going to be sp2 hybrid. With, yeah, 3 bonds, so you have 3 sigma bonds, 1 pi bond. And I'll explain that a little more in class, but you really just need to know if it's an actual bond, it's a sigma bond. If you got 2 things coming out the central atom, that's sp. It took one s and one p orbital, so 2 things to make 2 bonds. It took 3 things to make 3 bonds, the s and 2p orbitals, so that's sp2 hybrid, and sp3 hybrid makes 4. So, now that you got that labeled, this is a tetrahedral with 4 bonds. Okay, so I'm going to say 4 sigma bonds. Alright, and then I'm going to say this is sp3 hybrid. Looks like the only thing we're missing now that we've got all that taken care of is we're just missing the 3D structure. So, knowing what a tetrahedral is, you're just going to take this structure and just kind of twist it so it's the 3D tetrahedral structure, that one with like the 3 tripod and the one coming up that we're used to seeing from the model kit. So you got your central carbon atom. Okay, you've got 1 bond to a chlorine that's just going to be going inside the plane. You've got a second one coming down from the chlorine that's going to be inside the plane. Now your other 2 are going to kind of go this way and this way, both out and into the paper. So the one coming out, I'm going to draw kind of down like this, and I say it's in front of the plane, so it's going to be like that. Chlorine coming out, and then the one back here is like chlorine behind the paper. So this is my 3D model, this guy right here. So just be sure to box your answers. Well, there's a lot of answers here, so as long as I can see the drawings, you're good. But tetrahedral is an sp3 hybrid. Okay, that's how you do carbon tetrachloride. I'm going to let you guys do these ones on your own. For down here, it says draw Lewis dot and 3D structures for the following molecules. State best for molecular geometry, hybridization, number, type of bonds, single, double, triple, and for each of the carbon atoms. Okay, so this is pretty much the same thing, except you're going to have a slightly different structurally. You got 2 C's, 6 H's. So this one is going to be the carbons in the center, and then 6 H's along around it. Okay, so 1, 2, 3, 4, 5, 6 H's, carbons in the center. You guys get the idea. These 3D structures are going to be a little more tricky, but you should have the same kind of general geometry as you would from your VSEPR theory. Alright, you're just going to be putting them together on 2 atoms instead of 1 central atom. So hopefully this gets you a pretty good idea of what to do on this. If you need more help in class, definitely come and talk to me. Until then, I'll see you guys later.